Because like I was saying, thanks very much for joining us today. Um, I'm glad we have a few people really interested in this sort of session. We still haven't really kind of made up our minds, what sort of content we want to present, but it's sort of like a meetup. Think of it like a meetup where we have like very random presentations related to machine learning or NLP, whatever kind of content you want to present. The last time I introduced the concept, actually, I want to share my screen. I just want to talk, maybe take a few minutes more just to talk about it, what it was, what the idea was. I know some of you already joined us before, but maybe you just want to go through it for those of you that are new here. Okay. So you should be seeing my screen. Is that okay? Can you see my screen? Yes. Okay, cool. All right, as I was saying, the idea of this Keep Learning ML is basically to get together, and we want to do this bi-weekly. Initially, we wanted to do it like every week, but I thought that it could get a little bit too tedious for people. Giving some break in between, maybe 2 weeks will be great, and we can do this, set this up for every 2 weeks, so bi-weekly. The idea was to invite people that maybe want to present their work, present their project, present their paper, or whatever tool they found useful that they want to share with the community. That was the initial idea of this. And I think that's how it was used in the first presentation. So we had really interesting presenters that presented their research and their progress. So if you're working on some research, this could be a good platform to basically talk about it and get some feedback from people in the community. So the idea was to maybe prepare a few slides, maybe a 5-minute presentation, 1 to 3 slides. We don't want to go above that, but we decided also the last time when we got together that if there weren't too many presentations, maybe we will spend a little bit more time on the presentations that we were going to have for this particular week. If you have any questions about it, reach out in the Slack group. As we went through what it was the last time, and I don't want to repeat that. And you can find the video on YouTube. I uploaded it. You can find what it is and what it's about and what's the idea. But if you have any questions, it's not clear for you, just let me know and I can clarify to you if you have any ideas on what you want to present. So these are our past sessions. I'll try to update this as much as I can. Pretty busy these days, but I'll do my best. And that's the channel. So we have first presenter. I won't talk any longer and introduce generalizing to novel environments via reading. So this is some work from Victor Zhang, Tim, and Edward, and it will be presented by Te. I don't know who this is, but I think the person should be here.
Yeah,
are you here?
I'm here. Hi. Yep.
Hi, Tony. Oh,
hi.
Okay. I'll hand it over to you. What I will do is I'll hand it over to you actually. I'll make you the host and then you can actually, do you want to like share slides yourself or do you want me to go through the slides for you?
Well, I mean, I'm fine with you doing it. So the thing is, I'm joined both via my computer and via audio because I couldn't set it up via on Zoom. So I think it's fine if you just go through the slides.
Okay, makes sense. I'll do that for you then. You just let me know.
Yeah, so I think we can start with the next slide with the retified monsters. Yeah, so I mean, as I said, I'm Tony, and for this session, I decided to present RTFM by Facebook AI, which it consists both of a novel task and a model to solve it. And why I think it's interesting is because it's an instance of language condition policy learning. So unlike traditional reinforcement learning, where the goal is usually explicit in that the algorithm designer sets the goal, here the agent needs to actually reason about the goal by reading some natural language template. And as with most reinforcement learning tasks, here this is implemented as a video game. So you have some agent. The agent is supposed to defeat its enemy, and the rules are given by this templated language. And in the slide, I actually provide links where these templates are defined. So I think we can go to the next slide to show how this looks like. So I think it's easiest to explain on an example. So in the top left corner, you could see an example of a document which defines the environment dynamics. For instance, it notes that soldiers' weapons are effective against cold monsters. And then the next 5 frames show how an agent is supposed to behave in that situation. So you can see that in the first frames, the agent is avoiding the cold ghost, which is the enemy it's supposed to defeat. But then in frame 13, the agent picks up the soldier's knife, and at this point in time, it can actually defeat the cold ghost, which is its enemy, and the episode ends by the agent winning this episode. So I think we can go to the next slide now that we know what the task is, and how the agent learns to do that. I think it's the model is overall fairly interesting, although I won't go into the details. But kind of the most on a high level, it's important to note that it uses the standard deep learning toolkit. So it just embeds word tokens into 40-dimensional word vectors, and it uses bidirectional LSTM layers to create kind of a single vector summary of the current state of the inventory, of the wiki, which describes the environment dynamics, and of the task. And then it uses that short vector summary to modulate the CNN output, so to modulate each of the layers of the each of the channels of the convolutional output of the environment. And I think that the still pub link which I've provided is kind of a nice has a nice explanation of this feature-wise linear modulation, if anyone is interested in finding out more about how they do that. And finally, the learning itself is facilitated by using a curriculum. So the authors define 4 different environment levels, which starts easy. So at first, the monsters are static, they don't move, and the language templates are easy. And then once the learning converges on this environment, then the authors introduce a more difficult environment, and so forth. So basically, they transfer the same model throughout 4 different levels of environments. And the learning is performed by an implementation of Impala. Impala is a vTrace reinforcement learning algorithm recently introduced by DeepMind. And there is an open source implementation called TorchBeast, which is in PyTorch, and I've provided links to that too. So I think we can go to the next slide, which is a short kind of pictorial description of the model, which I mentioned earlier. So as I said, the inventory, goal, and document, they are summarized and concatenated together, and they are used as sort of a modulation for the environment. So the model needs to somehow find out who the enemy is and so forth, and that's supposed to be encoded in this short summary. And then the positional features consist of just a 2D grid where each cell is an integer describing the x and y coordinates of the cell. And the visual features here are just a bag of words. So you can imagine that there is a 2D grid, and each cell in that grid is a bag of words representation of the monster in that cell. So for instance, if you have I don't know, the cold knife in that cell, then it's going to be a bag of words representation of these 2 words. And in the next slide, there is a depiction of the cross conditioning. So I mean, the film layers are pretty straightforward. So you basically do an affine transformation of the textual features and of the visual features together. And then the output is a 3D tensor, so a grid which is the same size as the input, but then the channels are progressively wider and wider. And I won't go into much more detail. I think we can go to the last slide, where I just want to say that I think this paper is pretty cool. I think this entire domain is pretty interesting because it introduces new challenges in the language learning aspect of deep learning, and I think it's something that's necessary. That's going to be necessary as we progress towards a better understanding of the world of our deep learning models. And there are also some links I provide here. So I recommend definitely checking out the paper if you are interested in this. There is also an open source an open source implementation by the authors on GitHub, both of the code and of the task. And then there also recently there's been a nice ML workshop about language and reinforcement learning, which I recommend you to check out for some additional works. And yeah, that's it for me. I hope it was right on time, the 5 minutes.
Yeah, thanks, Tony. I think you did it in less time, but again, there's plenty of time because we only have 2 presentations today. This stuff is really interesting, as you said, right? It has a lot of there's a lot of implication for this type of research. Sorry about that. I just kind of muted someone. There's a little bit of noise there. Yeah, as I was saying, really interesting research direction. I think we have been seeing this lately. This really this domain, this kind of area of research that came up and trying to test language models. I think this is a great way. A lot of the community focuses on benchmarks and creating all these things to test the robustness of these models. But I think kind of having this tangent as well is really great for the community. So it's really great to see this this introduction here, I believe, and some of the resources. And thanks for putting it together. I think this NetHack learning environment is a great resource, and it talks a little bit about those challenges as we move forward with this line of research. So thanks. Anything else that you want to add, Tony? Anyone else that wants to ask a question here as well?
I mean, I don't have anything in particular to add. I just want to concur that this is very interesting for me too, and then hopefully we'll see more work in this domain.
Yeah, thanks. All right, so let's move on to the next one. I think this will be a really short one. Mani, are you there?
Ellis, can you hear me?
Yes, I can hear you. Yeah.
All right. Yes, I'm here. I was not able to join, but yeah, someone actually provided me a link, and yeah, I can join.
Okay.
Join. All right, I'll take it from here. So this was actually a blog post that I read this week about effective ML testing. Let's go to the next one. Everyone able to see the screen completely? If not, let me know.
I think I can see it.
Okay, sounds good. All right, so this is actually about my mind map of that particular blog post itself. So Jeremy Jordan, the source is available here. So he actually shared the blog post this week about why we need more effective testing for ML systems. So he actually started this blog post about what is the difference between traditional software systems versus actually ML systems. So in case of traditional software systems, you typically have write the logic of your in the code and actually write test for your expected outputs. But in case of actually ML systems, that is completely a different paradigm, right? Where you have like a pairs where you have the input sample and then the output sample, and basically you build a model. So how can we actually able to ensure consistently whether the model is actually producing the desired behavior? That consistency is the key there. And then he went on actually just to give you in case of the left-hand side, the different tests that we actually perform in our in our traditional software systems. I don't know how many of us actually like are familiar with the the tests available here, but just to make things real quick here, unit test, everyone knows, we typically run on a single unit, typically a method, and it's supposed to be really fast. You actually, and then the integration test, this is a higher level actually test where you actually ensure that all the different components in your system works together and function as a whole. And then regression tests, typically if there is a bug occurred in your system, you want to ensure that you write a piece of code that can reproduce the bug, and as well as once you actually fix the bug, you write test for it so that that bug doesn't reoccur again. That's regression test. And smoke test, these are the tests that he did not mention, but I wanted to add here. Smoke test is typically once you deploy your system in production or in any other forward environments like QA stage, you typically want to ensure is the system started correctly. So you typically have something like a small smoke test to ensure that your system is live. And so before you actually route traffic, that's kind of what we call a smoke test. And then the load testing, this is whenever we are actually like where you want to ensure that your system is able to handle these many. There are specific requirements that your system needs to provide response time at within like 500 milliseconds. So you typically perform load testing. So these are some series of tests that you perform in your traditional software systems, right? Now, how is it actually different? Now, all these are still actually need to be done even for your ML systems as well. But these days, like what he mentioned was, we typically run, we train our model, and once we have our model, we have the model evaluation, which is on a validation set or a test set. You provide the performance metrics and as well as the visualizations. That's one series of But the other part, which is the exact model testing, is not that actually comprehensive. The reason why, because I don't think like everyone actually really thinks about the failure modes of the system, because so there is not really a lot of systematic approach towards how to actually perform model testing. It is very, very critical because your system actually the ML systems actually fail very silently, and also really sometimes very gradually as your data changes. So here they provide, as you can see, like there are like pre-training tests and then there is post-training. So pre-training test, as the name indicates, that you perform these tests before training the model. Okay? This would actually saves a lot of time, and it's really a short circuit. So before beginning training a model, right? These are the some of the tests, which is the first one is ensuring the label alignment. Basically, like the number of check the shape of the model output is actually aligning with the shape of your labels. That's the label alignment. And then and the second one is the output range. You check for the range of values that is produced by the output, because, for example, typically in classification, you expect the probabilities of the outputs to be from 0 to 1. So whereas in multi-label it would be different. So so that's why you have to actually check your output range. And then the third one is assertion about your data sets itself, whether like it should expect to actually like have a certain number of columns, or is it like features. So there is a great tool called as like great expectations, which I have added a link as well, that could be used as well. So, and then this is where the post-train part, this is the most interesting part of it. It actually comes from the checklist paper, which actually I think it won the ACL award, if I'm not wrong. which actually provides a set of defined scenarios to actually test the model behavior. So as you can see, initially I was really, when I was doing my project, it's mostly I was checking for just the minimum functionality test part. And the other three tests really, gave me some additional insights about what are all the things that I should really consider as well. So the minimum functionality test, one thing which that we need to keep in mind is identify certain set of individual examples where, irrespective of whatever model, either neural network or a simplified model, you have to identify a certain set of individual independent examples that the model should always produce the, the expected output. So it is one of those things that that we might miss out on, whereas like where it actually performs better on the overall like validation set, but somehow these simple individual examples misses out. So it would actually like help us identify those regressions. The other part, which is these are all like called as like minimum functionality test. Another part which the blog mentions is about testing on really a subpopulation in your data set. What does that mean? So either if you are actually testing for a group of people, right? So whether specifically like identify a demographic, basically like identify a certain set of list of criteria where you can identify a subset of data and evaluate on those subset itself. So that is one other additional thing. And Snorkel, I don't know how many of you heard about Snorkel, is a tool for like data labeling with peak supervision. It allows you to create certain sort of called as like slicing functions where you can provide a criteria, based on which it can give you a subset. So that is one way to actually look at as well. The second part is the, let me go with the invariant test first. So invariant test, where you make certain set of changes to your, they call it as perturbations, to your input, that it should not actually like really impact the output. So this is typically applied, as we are doing the data augmentation part. The same concept is applied in the testing itself as well. So, and the last one is the directional expectation test, where you have certain set of perturbations to your input, but you really want that output to change. For example, changing a particular keyword, from makes a sentiment analysis output, sentiment classification output to change from positive to output. So it is an expected change in the output. So you actually really test for that as well. So that's the overall like summary of that particular blog post. I hope this is useful and you can actually leverage it as part of your current project or in your future project as well. And definitely go and check out the whole blog post. And the paper as well. It's pretty good. Thank you, Elvis. Any questions?
Thanks, Manny. Anyone has any questions about this one? Okay. And yeah, and you really mentioned that paper. Yeah, I read the paper and I found it really interesting, like the tests that are proposed in that paper. And I was thinking like, how can you like really use this in the real world? How can you actually do this kind of test? And I think this blog post has, I think, some insights into how you may be able to do that. And you actually shared some examples. So yeah, I think this is great stuff. And I really like how I think you created this model right here, right? Like this drawing.
Yeah,
it's really
kind
cool.
of lazy.
Yeah, yeah, but this is really cool. I mean, when I read, I don't really take notes this way. Like, but this is really nice, very straightforward. You can see here the different steps. So thanks for putting this together, man. It's really, really helpful.
Yeah,
like a little mind map. Yeah. Okay. I'm gonna do the last one. Just take a couple of minutes. I won't take too long with this one. I really wanted to kind of do a little bit of an exposure for this library. I think it's a really interesting library. I've seen like many different libraries that are coming up lately. And one of those things that people talk about is compatibility, right? So when you're learning, let me just go to that slide. Okay, it's not updated here, but I can just refresh it. So I just added, like, while you were presenting, I just added it. Okay, so here it is. So it's EagerPy, right? What's the idea behind that? Let me just take you to the to the repo. So as I was saying, a lot of people are looking for tools that maybe are compatible, say, with different kinds of models that were built with different libraries, like PyTorch, TensorFlow, JAX. And I remember when I was doing my research, and I used to use both PyTorch and TensorFlow. So I used to have to do a lot of like duplicating of code. Right? So when I designed my experiments, I was doing that duplicate of code. And I always thought like there must be a tool out there that I can use that certain parts of this experiment, maybe, you know, I don't have to duplicate them. So I don't have to create a code for PyTorch and then I have to create the same code for TensorFlow, my TensorFlow version. So I was using both of them. And recently this one was announced, and I don't know how recent, but I think it's like 10 months ago or something like that. But recently I ran across this one, EagerPy, and they basically built a framework that, you know, allows you to build code that natively works with PyTorch, TensorFlow, JAX, and these are the popular like deep learning toolkits. So I'm really excited to see this sort of tools and efforts because I think it makes a lot of sense, especially for research. I don't know how you would use this in the context of like maybe putting something into production. I'm not quite sure if it's there yet, right? But I think they even built a tool. So let me just show you that. They even built a tool for, I think Manny mentioned this as well, to do some kind of adversarial attack. So, and you know, you can actually use models that were implemented in either PyTorch, TensorFlow, or JAX. So this is one really good use case. You build one code to do this attack, and you can actually, you know, do this on any model that you found out there that you just want to you know, test this on. So if you look at the examples, I think the examples here, for instance, on a ResNet, you can see here that ResNet, obviously this one is about PyTorch, but I'm not sure if they provide, yeah, they even have the TensorFlow example. So they have the TensorFlow, they just import the models and they do their test using EagerPy. So that's really, really interesting to see. And this sort of efforts, I think, make a lot of sense. And obviously the benefit here is it's almost like, instead of using NumPy, use EagerPy, right? So, you know, you can actually achieve it with NumPy, but if you do it with EagerPy, I guess they're claiming that you get sort of like performance, which is going to be always the reason why you want to use libraries like these. So that's really great to see. All right, so that's all I wanted to share. Any questions on that? I haven't really, like, to be honest, I haven't really went into the tool. I saw the examples, like the different notebooks, and I saw this example and I got quite excited about it, that you can actually do this already with this sort of libraries.
So can we ask question for the previous slide?
Anyone that you want. You could even add any question and open a discussion. We have some time.
Okay, so Mani, I wanted to understand about min functionality test on the models, that is post-training test. So if you could touch on that, like.
It's basically minimum functionality tests. So what I meant by that was, you know, for example, there are sometimes where you change, so any changes in your data or code would actually cause your model outputs to change, right? So here in this particular case, the minimum functionality test is, you know, I call it as like, these are like part of invariant test, where, you know, irrespective of whatever change, you want the model to always produce certain set of you know, this expected output that should not change. Okay, even if you add data, remove data. So you basically identify these examples, which as a human, you can easily tell. So you definitely want this model not to regress in the future. So that's what it's called as like minimum functionality test. So you basically like identify, carefully curate these individual examples, and you want to actually ensure that like the model always produce the expected output.
Okay,
That's what
so
it is.
so this one might work best in case of classification system, but how would it work across, like if we
That's a
start looking at different models, like
Mhm.
you start talking about the regression systems where you have regression models,
Right.
or the models which are not just doing like more like binary classification, or they have like large amount of classes, and
Mhm.
that's like more of a ranking problem.
Mhm.
So in those cases it will become like more of like test attacks. So
Mhm.
aren't we gonna be biased towards like when you are gonna have some holdout test, because models are always gonna be predictive, and
Mhm.
their like scores will change. So how would we say, like what would be the metric for us to just say like whether it passes the test or not?
Right, of course, you're right. For classification, this would work, but for regression, I don't think this would. You would actually want to have some. That's where you get to creative. You get to be creative. So you probably like would for like choose a threshold or something like that in those
Mhm.
particular case, like where you do not want the model to fall below that, right? So yeah.
Okay, so if you can just like one by one explain to me like this subpopulation using slicing function. So what you meant by that?
Subpopulation meant in this particular case, I was actually thinking about the classification itself. For example, if you
Mhm.
choose, in case of, say, for example, there was a number of examples where, for people of a certain color, image classification actually predicts it as completely like, doing incorrect predictions, right?
Mhm.
So you want to actually like identify, is it working on the overall like data set, or is it whether to identify like for certain like subset of your data, how is it actually really performing. So the slicing function is one of those things that is available using a tool called a Snorkel. I
Mhm.
have to check it out as well. Basically, Snorkel is a way to actually like programmatically like create labeling functions. So you define a criteria and then you can programmatically create. So it actually also has these kinds of slicing functions where you can actually able to identify a subset of data. I have to check it out as well. But this is one of those things the blog post actually mentions.
Yeah, this is really interesting actually. It's like when you're working with the images, you might look at some of the demographics,
Mm.
and you might be looking at some certain set which is always giving the wrong prediction.
Right.
So we might want to tune our model towards that. But it's like trying to get all the knobs right. So when we are going to do that, so aren't we introducing some bias just by picking up and finding out like, okay, after training I have figured out, and even after validation and everything, I'm again trying to find out what's wrong with my model, and then
Mhm.
I'm going back to fix that, and somehow I have exposed my test set again, and then I'm going to introduce it to train.
You
You get my point, what I'm trying to say.
Yeah, but the thing was, you definitely want to actually like identify the spaces where like, because it's sometimes
Yeah,
it can actually help you avoid the embarrassment sometimes,
yeah, I
when
get my
people.
point.
Yeah.
Yes, yes. Okay, that's what I wanted to like ask in this set. Like because from if we are gonna like you have taken all integration, regression, smoke, and unit and load test. So I did not see the load test one. So if we're gonna talk about load test, so how would we do with this model? And what would be that post-training testing or pre-training testing relative to that load test?
Load test is basically like how many in case of online predictions, how many requests can your system handle, right? So
Yeah.
you definitely want to actually test that and ensure that if your business has a specific requirement of that the response is to be within like less than 500 milliseconds, the prediction response is to be less than 500 milliseconds. right?
Right.
So in that case, you definitely want to run a series of like using 500 users, 5,000 users, how many really can handle, and then provide additional resources, compute resources, if needed. So that's what load testing is.
Yeah, so I was thinking in terms of like when in terms of load testing, when we convert to ML system and like we have like suddenly a news comes in, and and on the basis of that news, suddenly Twitter and Google, and there will be a lot of articles and searches will get skewed towards it because there are continuously learning systems. So in those kind of continuous learning system, if sudden data drift happens for a particular kind of the data points, so would that like how would we test it in for before going towards like production? So I was thinking in that terms. You understood what I'm trying to say?
Yeah, in those particular case, you before making your like system available, right, you typically do it. There will be a knob switch that would happen, right, where
Yeah.
yes, this at least even if it is a live data, you still have a window where you want to actually aggregate, and then so I'm not really sure in that particular case whether you will because in load testing you want to ensure that before making that system live, you have these are all the things that should pass, get a tick mark. So yeah.
Yeah. So Elvis, any
Yep.
idea on that?
No, honestly, no. But I have to
Okay.
dig deeper here and try to look at some of those links myself. I think all of this stuff, to be honest, is it's new. All of these ideas are new, I think, and that's why it's hard to get those answers.
Yes.
Yeah, I really like the discussions and the questions. They make a lot of sense, I think. Anyone else wants to ask anything about the presentations today? Anything about the session? Anyone wants to add anything? Any feedback? I would appreciate that. Just let me know if this is working, if you like it, if you prefer to do it anything different. Anyone on the call?
Next time I would try to do some code walkthrough. So I
Okay.
think people might like that.
Okay.
So we'll take
Yeah.
a topic or maybe something
Yeah.
which is very like basic and start with that. And
Yeah.
so it
I
might
think
become.
that'll
Yeah.
be great. That'll be great. Someone was mentioning an idea of trying to do like say like a wish list.
Yeah.
Maybe like we could design a wish list, so we could probably start a document or even open a GitHub issue, and people can submit like what they would like to learn more about. Because I do suspect maybe that people that are just getting started may appreciate maybe an introduction, say, of a transformer or something like that, or an architecture, a new architecture in deep learning. So I think that would be great. That's a really great idea. I think like the wish list. I did kind of propose some ideas on what you can present. It's in the GitHub repository if you don't know. All the list is there, but I can add more to it and be more specific about it. But I want it to be very open. I want it to be about discussion. I want us to have discussion, even if it's something philosophical. I want this to be like a platform for that. And I really appreciate Mani and Tony for presenting today. Those are, you can see they're very different topics, but people are really passionate about this. And I like that we are talking about stuff that are more on the cutting edge and in terms of production and ML and research. So I really enjoyed those presentations today. So thank you to both of you. Yeah, so I think that'll be it. If you don't have any questions, maybe if you have anything later on, please let us know in the channel, or you can ask me directly. And I think we'll be seeing you again in 2 weeks. So we have plenty of time. Anything interesting that comes around, maybe you want to pass it by me or something like that, let me know, and I'll let you know if it's okay, or you can just add it. You don't really need to go through me. And the whole idea of this is to be open and flexible. So thanks everyone. Have a good weekend.
Thank you.
You too.
Bye.
Thank
Bye-bye.
you.
Thanks. Bye.
Bye bye.